Hi, we are Dan Bowers, Ryan Glynn, Dan Ignatowski, Jake Sparks, and Shane Turecki, and we are the multi-track team, obviously named because our vehicle consists of both back tracks and a frontal actuating track in order to climb the stairs. In this video, we will walk you through our original design concept as well as the changes that we made to it. After that, we will show you how we built the vehicle and demonstrate where we are at this point. This is the original design concept with the 4 tracks. The treads are not shown in this drawing, but if you can imagine the treads going along the wheels, that is what the design originally was. The 2 tracks at the front of the robot actuate up and down so that the robot can go from a 90-degree angle to completely flat. The robot is designed to be half a meter long when the arms are at 90 degrees in its starting position, and then drop down to a flat position with a length of a full meter. This allows the robot to have 3 points of contact along the stairs while climbing it. We decided that the 4 tracks wasn't necessary, and we could achieve our goal with just 3 tracks. As shown here, this is our current design. This cuts down on the weight of the vehicle, along with making it easier to manufacture. This drawing is a little bit more detailed, so you can see the treads how we originally wanted it. You can also see the 2 driver motors at the very front of the horizontal tracks. On the chassis next to the MyRio, you can see the stepper motor that controls the rotation of the front arm up and down. This is the final product of the drawing that you were just shown. You can see that we decided to give it a higher leading edge because that way it gives us a little bit more room in which to hit the stair. This is the robot in the starting position with the arm at 90 degrees. This way it fits within the half meter by half meter requirements. And this is the flat orientation of the robot. Here it's easier to see the 2 driver motors that sit on the chassis, along with the 3rd driver motor at the front of the front arm. As stated before, the flat orientation allows the vehicle to have 3 points of contact along the stairs while climbing it. This way, once it has passed the first couple stairs, it should be able to climb straight up them as if it was on flat ground. Here is a 360-degree view of our vehicle. At this point, I'd like to talk about our process in manufacturing the vehicle. The first thing that we wanted to focus on was building the chassis. We were able to find a piece of abandoned aluminum that was already welded that we thought would work as our chassis. However, this chassis was a little bit heavy for our liking, so we decided to manufacture our own chassis using thinner aluminum. This cut the weight of our chassis by more than half. This is our new chassis with the treads and driver motors attached to it. The treads are able to snap apart and together easily. This allows us to get the optimal length for the treads that we need. Unfortunately, the treads do not provide much grip. They really just slid along the tile floor rather than gripping and moving forward. So we realized that this was a problem on the floor, along with that the track would have a very tough time getting traction on the stairs and climbing them. We thought about applying some sort of rubber tape over the treads. However, you can see that there are tiny grooves within the treads that makes it difficult to apply it across the entire surface. Besides, we thought that this tactic would look a little bit unprofessional, and so we wanted to go with something that would maintain the look of the vehicle as well as improve the performance. The solution that we came up with was to buy Plasti-Dip and apply 5 coats of it to the track, as you can see. This greatly improved the traction of the treads to the point where you need to apply a lot of force to get them to slide at all. This is a better picture of the tracks to show its functionality. You can see that the shape of the track is formed by wheels that either turn the track itself or ride along it. The front wheel, which is slightly elevated, is attached to the driver motor and provides all the rotation for the track. The rest of the wheels are simply bolted onto the chassis. All 3 of the tracks share this basic configuration. Besides the chassis and the front arm, we also built the brackets that attach the motor to the chassis itself. This allowed us to save money rather than buying it from the manufacturer of the motors. The brackets for the driver motors are L-shaped and found next to the tracks, while the stepper motor is mounted by sheet metal bolted into the chassis as seen in the foreground of this picture. The MyRio will be attached by brackets that encompass their corners without putting any stress on the device itself. This is where our budget went. All of the purchases seen here have already been made and delivered. We are just under budget at $244 with no more foreseeable purchases left. All of the manufacturing is completed at this point. We are currently working on the LabVIEW programming in order to finalize the project, but we can demonstrate the functionality of the motors as seen in the next two videos. Thank you for watching our presentation. We'd be happy to answer any questions that you have for us at this time.